general solution, general solution, general solution. It's not something that you can expect to fail. You can't expect to fail this part. You have to pass it no matter what, you like it or not. It's a must for you to pass the general solution. General solution part, I will just start by doing the simple or the core basics of trigonometry before we can that. We have this page here. We're having the Cartesian plane. Cartesian plane, we are talking about something like this set of axes. Set of axes is made up of the y's here, you can see, and also made up of the x's this side. These are the positive side of x and the positive side of y, and then this side is a negative side of x. On this side, x is negative, and this side, y is negative. So which means over here, this point is origin. Point origin, it means the coordinate of point origin is 0 and 0. 0 and 0, or 0 is to 0. Someone can say that 0 is to 0 or 0 and 0. So on this one, we are not mostly focusing on the coordinates, but we are most focused on the angles. So you can see those angles we're talking about the angles that are drawn or that are given from the point of 0. You see this part where the line x here angle is 0. The first angle here is 0, which means we're on this line, this line we're talking about here, the angle here is 0. So when the angle goes anti-clockwise. Anti-clockwise meaning what? They come from right going up to the left. They come from, this is the right side. How do we say it's the right? The center O, or the origin O, 0 is to 0, it determines the left. This is the left, and determines the right. This is the right. So from right going up to the left. So you can see my arrow here. This is where the angles are going. These are what we classify them as the positive angles. So the angles comes from a set of axes on the positive side to the negative side of axis to the negative side of y, and also coming back to same side, which is they will be making the 360 around the clock, which is 360 degree. We call it the revolution. Now, the first angle that they are making here, from this point, we can see the triangle here, the small triangle that can be drawn in this manner. This small triangle, now it's having 90 degree. This line that is drawn here, this line here is perpendicular to this line of axis. So which means this is the line of y and this is the line of x. The two lines are perpendicular at each other. The point where they meet, they make an angle of 90 degree. That's what they mean. They say perpendicular. And then going further, now there are now 3 angles involved in a triangle. We know that there are, yes, 3 angles involved in a triangle. We know that in a triangle, something like, let me just draw a simple triangle here so that we can understand what we are talking about. Triangle with side 1 and then side 2 and then also side 3. Side 3, let's put the blue one. Side 3, let's put the blue one. Now, make sure that the triangle that you are talking about is a right angled triangle. What do you mean a triangle is a right angled triangle? The triangle itself, it has what? It has a 90 degree, or the two lines that are perpendicular. Now here, this triangle, you will see this triangle familiar, or you will see this triangle in most cases when we draw up, also when we come back to something in a Cartesian plane, or just drawn within or out of the scale. So let's come and see to it. Now this triangle, it has the 3 sides. Side number 1, which is this one, and also side number 2, which is this one. I'll just put the 2 line, and side number 3, which is this one, I'll put the 3 line. Now this triangle, it has an angle. One angle on this triangle is 90 degree. So the type of triangle, we call it a right angled triangle. We call it a right angled triangle. Right angled triangle. These are the kind of triangles we'll be talking about from now onwards, going further, that you will see being drawn in most cases of trigonometry. So the triangle has to be right angle triangle so that these principles can apply. Now we have to label our right angle triangle. After labeling it, it has the 3 sides. Now the 3 sides of them, one of these sides has to be x and the other side has to be y, and that be R. Now, what is the X side? The X side, we call it an adjacent. And what is the Y side? The Y side, we call it an opposite. And what is the R side? The R side, we call it a hypotenuse. Hypotenuse is the longest side on the triangle. The longest side on it, it's hypotenuse, as I was saying. It's called hypotenuse. Now, this hypotenuse that we are talking about here, we see it by labeling the right angle first on a triangle. And then I used to tell other kids that when you have to know which one is the longest side, just throw an arrow from right angled side. Just throw an arrow like this one. And then the arrow in which it points, the side in which the arrow points, that side is it's an R, or hypotenuse, or the longest side. So which means, according to label, the green light here, or the green one here, is what? Is our longest side. Why? Because it's opposite to the 90 degree, or is opposite to the right angled. So now we have to classify between what? Between the X and the Y. Between what? Between the X and the Y. Now, this one is very simple to classify between the X and the Y. Now, upon the angles, look at the three angles inside. We are given three angles here, but only labeled one. We are only being labeled angle of 90 degree. So the angle of this side, is not labeled. And also the angle of this side is not labeled. So which means, Warren, when we come to this part, be careful on the angles. Now, if the angle is labeled, let's assume, for example, we're taking an example now. So when you take an example, it means for whatever we talk about on our example is correct or is true. Now, let's see. On our example, we are having side A, we are having side B, we are having side C. Let's label our side. Let's assume this is side A. The first part here is, and then our angle, as we keep on labeling, this is side B. Where is side B? Side B. Okay, A, B. This is our B. And then let's put our side C this side. This is our side C. Where is our side C? Side C. Now, on our side C, we see now we are having a triangle that is labeled. So which means automatically our R, we go back, we give a reference now. Our R is equal to line AB. So line AB is automatically equals to R. Now we know, because we have given what? We have given the label. Now, we are looking to find or identify X and Y on this triangle. And we are only given 90 degree. Now the examiner will give you the angle, where the angle is positioned between angle at A here and the angle at B here. There are only the two unknown or unidentified angles that we have to find before we can now consider the X and R of this line. Remember, we only labeled the green line. We didn't label the blue line. We didn't label the yellow line. So we need to know where is the angle positioned. Let's say, for example, angle is positioned at A. So if angle is positioned at A, we are going to have these properties saying that single trig ratios, we are having sine, we are also having cos, we are also having tan. These are the three trig ratios. Now, if angle is at A, it means it's going to be tan A, it means it's going to be sine A, it means it's going to be cos A. Now, which means now, after we do that, let's give the labels to this side. Let's give what? The labels. Now, how do we then give the labels? If now our angle is labeled or is given now to know that the angle we are looking for is angle at A, and here is our A, it's automatically that it's going to be easy and simple for you to label X and Y. How do we do that? Let's look at the lines that are perpendicular to one another. Okay. The line that is perpendicular to one another, and then which is line BC and line AC. These two lines are perpendicular, meaning they meet up at 90 degree angle. Now look at the line in which that the angle is at. So now between the blue line and the yellow line, where is the angle A at? Now angle A is on the line, yellow, and line yellow is line AC. So automatically now it's going to be simple for us, or for me and you, to label that. Now we see that since we now identify that our angle is at A, and then if angle is at A, we now identify that the line in which the angle is at, we say that is the yellow line. Now, in the yellow line, we automatically can see that, whoa, okay, now the yellow line, which is AC, now AC will become our X on this side. AC will become our X. So which means now our X is equals to line AC. So automatically it gives us the remaining side, which is now going to be BC. Now we will just refer it automatically to Y. So you see, if you can now know how to figure out the side which is the longest side, hypotenuse, and also the side which is the shorter, the other side which is the opposite, or the not opposite, the adjacent, which is the X, then it's gonna be easy to figure out the last one. So these are the trick way to find or not understanding what are they talking about. Now, I've brought the three trig ratios here: simple sine angle A, cos angle A, tan angle A. Now, what are they equal to in terms of X, R, and Y? Okay, now, sine angle, which is angle A, is equals automatically, sine is Y over R. It's Y over R. And then cos angle will be X over R. While tan angle will be Y over X. That's initial. So now, since we have given our labels in terms of A, B, C on this triangle, now we will figure out sine A. We now know that sine B equals Y over R, and Y, which is BC, there's going to be B divided by R, which is AB. So if whenever we see sine angle A, we will just simply put BC over A, what it will lead us to. And then going further, when we see cos angle A, which is X over R, we'll just simply say it's AC over line AB. And then the lastly, which is tan angle, which is equals to Y over X, it will simply be equals to Y, which is BC, divided by the line AC, which is line Y, and then line X, which is line AC. So automatically, these single trig ratios, you can just, when you see the angle, you can just simply substitute the angle by the sides, the ratios of those sides. We call them the trig ratios. Now, this is when we have chosen the angle R. We have chosen the angle R. Don't forget that. Now, the examiner will give you an angle that they want you to distinguish or to talk about. So let's assume that, remember, we are in this angle. We have the angle at C, which is 90 degrees. That one is simple, with no need of anything. It's a special angle, 90 degrees. And then complicating part is figure out angle at A and angle at B. So now we just did an example of angle at A. Let's do the other example of angle at B. So now if it's chosen that, we are now given the angle at B, given angle B. Now, what do we do? So which means we must find sine angle B being equals to something. Automatically, it will just still be Y over R. Still be Y over R. Don't forget that. It will still be Y over R. Y over R. As long as it is sine is Y over R. If it's now cos, if it's going to be cos, it will have something like cos angle B, which is equals to, which will still be X over R. X over R. But the same X and R and Y we're talking about is not the same as we are given here initially. I will just come to that now. Then if we have tan angle B, it will still be equals to Y over X. But now let me get to the complicating part. When we say sine angle B is equals to Y over R, when we say angle B is equals to Y over R, I don't mean that it's now to be equals to this one, which are now BC over AB. No, this is just a single initial formula for sine angle, which is opposite over hypotenuse. That's what it means. So now let's see, which means now we have to start afresh and label our triangle. Which one is X, which one is R, and which one is Y. Let us ignore the one we have figured out at first, because this one they only apply if we have chosen or we are given that the X is angle A. Now we are given that the angle is angle B. So if it's angle B, now the statement or the information now changes. What changes? Which is the last part. The last part changes. But this part remain constant or remain the same. It doesn't change this one. It just remains. Angle is just y over r, cos angle x over r, tan angle is just y over r. They remain the same. Okay, let's go continue and now figure out and label this triangle, this one, in the term of now given angle at B. Now our angle is here. So if our angle is here, don't forget the principle of saying that wherever there is a 90 degree, this one is a principle of me. Don't say there's a principle in the book, let's go and figure out the principle. No, this is a principle of me at helping you identify them. Wherever there's a 90 degree, just throw a simple line going this side, and then you figure out the side in which the arrow it points. That side is R, or hypotenuse, the longest side. So now, which means our new R is different. Now let me write this. We're gonna have our R, we're gonna have our X, we're gonna also have our Y. So now, which means R different from this one. Remember, it's still the same triangle, different now information that you are figuring. Now, our R, which is gonna be equals to longest side, is still what? Still AB. You see, still AB. This one, it didn't change in most cases, because yes, it doesn't change, because the angle 90 is still the same position where we knew or we saw it at initial. So there is no changes on this one. So let's go and figure out X. This is the complicating part. If you can forget or neglect how to figure out this thing, you'll come back to the trigonometry and say everything is difficult. Now let's start to see X. Where is X? I said that my principle angle that is given and the two lines that are perpendicular. Look at which the angle that is given is on which line between the two perpendicular lines. Now, the angle given is B, which means is that between the two lines that are given, which is perpendicular, is AC perpendicular to BC or CB. Now, the angle is on line BC. So if now it's on line BC, it's one of the two perpendicular lines. The other perpendicular line to BC is what? Is AC. Now, which means what in BC itself, it becomes our our adjacent. It becomes our X. So which means now our line BC becomes what? Our X. So if we now can compare this one with the previous part we found on the other part when angle is A, you see now they are swapping X and Y, they are swapping. So don't be confiscated next time when you see these things and then you see that they are interchanging. How are they interchanging? Is because of this understanding. Where is it basically coming from? Now let's see. Automatically the last part is going to be simple. We know that the remaining one, which is AC, it becomes what? It becomes OC. Then without. That is the first thing you have to do when you work with the triangle in trigonometry. Figure out that triangle, 90 degree, figure out adjacent, opposite, and the hypotenuse, please. And therefore now it's going to be simple. Since we say that here, we come back here, sine angle B is Y over R. Then it's going to be A divided by R, which is AB. And then we go back, we go down to angle, cos angle B. Cos angle B is still X over R is still X over R. And then what is the value of X? You see now, these things are not changing, but the values where they are positioned to the sides themselves are changing. But to say that cos is X over R, it will never change. It will remain like that. But which side is X on the triangle, depending on the angle given, which is angle B. That's how I taught you how to find it. Now, going further, let's see which one is X. X is BC, then divided by R, which is AB. Then the last part, which is tan angle, which is Y over X, which is tan B is equal to tan B to Y, which is AC, divided by X, which is what? What is the value of X? X is BC. Now, which means when they say write this single trig ratio in terms of something, it means when you are given these things, you have to figure out these ones. Now, we will get to those things on the other topic, not this one. Here, I'm just bringing out the methodology of doing the triangle on this one. Now, before I proceed to the main course of the day, so which means automatically I have explained this triangle simultaneous. Everything here I explained it, because on our small triangle we are given angle theta, and this is our angle theta, and our angle theta automatically, remember, it's on the set of x's. You will know which line is x here. It's going to be simple for you to just cram it, even though you don't know. But now, since I drew this triangle separate, you know how we figure out this one. So now the angle theta was given this part, which is on the line of x. Automatically it's on the x because it's on the Cartesian plane. Okay, let's figure out sine angle is still y over r, cos angle is still x over. It doesn't change these ones. They should be there. Let's go to the next part of it. Okay, now on the Cartesian plane, we input those ratios, trig ratios. When we say all, we're talking about sine, we're talking about cos, we're talking about tan. Here we're talking about the quadrant where these trig ratios are positive. What are the quadrants? Quadrant are the side of set of x's. Side. What do we mean the sides of set of x's? Here on the set of x's, we are having side number 1, which is this one, which is, we call it quadrant. Why is it quadrant? Remember, this is a perpendicular side, and is this side. The quadrant is this region. So it's number 1. So this whole circle is divided into 4 parts. Now becomes 4 parts of a circle. So each part is called a quadrant. Let's go back here. You see here. Now the circle is divided into 4 parts. Part number 1, it's quarter number 1. Part number 2 is quarter number 2. Quarter number 3 is quarter number 3. Part number 4 is quarter number 4. Now I was reading clockwise, meaning we're starting from the top going to bottom, clockwise. Now in trigonometry, we're reading anti-clockwise. From here, we're going backwards in this way, anti-clockwise. This is anti-clockwise, and this is how we read in trigonometry. Now, this every quarter of a circle, we call it a quadrant. Now, quadrant number 1 is on this side. It means over here, sine and cos and tan, all of them are positive. So which means we have any angle less than 90 is positive. We have angle like an 89, 88, and then angle 87, 86, 60, 30, 45, until angle 0. All of those angles, when you put them, if it's, let's say it's going to be cos angle 89, it will give you a positive number. No matter it's 0, what, but it will be a positive number. That's why we say it's a positive number. It's on the first quadrant. When we say tan 45, it will give you a positive number on a calculator. So it's on the first quadrant. When we say sine 20, it's a positive number. No matter it's 0, something, it's on the first quadrant. So this side, every value is positive. So here, ranging with the angle, here it's angle 0 up to this part here, perpendicular line, meaning what the angle is what? Is 90. So on this line, the angle is 90, which is this line. The two lines are perpendicular here. So the angle here is 90. So from here is 91. 91 going to straight up to here. Here is 180. So which means from 0 up to here, which is this one, is a straight line. So angle on the straight line, they equals to 180. So this side is 180. So from 180, and then this quadrant, we call it the second quadrant, which is quadrant number 2 on that circle. Now from 180, we zing going down, counting, we add by 90 from 180, then we get 270. So 270 is more like 90 times 90 times 90, 3 of the 90s. When you decade them, they will give you something like this one. Get tan. It means tan on the quadrant. Which quadrant is this one? Quadrant number 3. This side tan is positive. So how do we know that tan is positive this side? Remember, the x value here is negative, and also the y value here is negative. So it's on the negative side. So remember, tan and cos, tan is equal to y over x. It's going to be negative y divided by negative x, which is negative divided by negative gives you positive number. That's why we say tan here is positive. Then we go from 270 going, zing, we add another 90, then we will get 360. Now when we get 360, this is quadrant number 4. Quadrant number 4 It's only cos that is positive. It means or the value of tan here is negative, the value of sine here is negative. What do we mean if we say, for example, cos 360 or cos 359 or cos more than 2, okay, cos 271, cos 271, you'll get a value that is positive. But when you say tan 271, you'll get the value that is negative, even if it's going to give you undefined. Just give you an example. That's what they're trying to tell us in this part. Understanding of the quadrants is just to know where is this trig ratios positive and negative, and also the values, where are these. Let's say, for example, they have given you something like sine 225. Let's say sine 225. Now sine 225, it's more like a simple thing, but let's see if it's more like a simple thing. Let me just okay, let me put the calculator efficient. Okay, now here's the calculator. Now sine 225, let's see 5. I'll just put sine 225 here on my calculator. Okay, let me find it. It looks like okay, sine 225. Now when you see sine 225, it gives us negative 0.7. I don't want to the other numbers going further, but it's negative 0.7. So if I want it in a form of a fraction, it's going to give negative root of 2 over 2. When you punch it on your calculator, if you can't see my calculator there, it's okay, but it's fine. But it's negative number. So what do they mean over sine 22? Where is sine 225 here? Let's position sine 225 here and see on that position is sine 225 negative now. Now here is when angle is less than 90. 225 is more than 90. Sine is not here. Here angle is above 90 but less than 180. 225 is not here. But here on the third one, angle is more than 180 but less than 270. Okay, from 180 we will pass 225 before we get to 270. So now sine 225 is on this quadrant number 3. And let's see which one on quadrant number 3 is positive. It's only tan. We are only given what? Tan. Which means so in the one that we are not given here, drawn here or written here, they are negative. So which means in this side, sine is negative, and also cos on this quadrant, on this one, is negative. That's what they are trying to tell us when they written this one. This side, they are negative. So it's only tan that is positive on third quadrant. So sine 225 is negative number. And we saw it on a calculator, it gives us negative root 2 over 2 or negative over root 2 or negative 0.70 diakwa. That's what they mean when they say this one. And every time when you're working with this trigonometry stuff, please throw this thing aside. Just write them like this. Some of you use the sample called a cast. Cast will tell you, where does it start? Start from fourth quadrant. You see here. Just for labeling. Why start for first quadrant? Just to claim it to label or on fourth quadrant. Which one is positive? Which one is positive? All of them on the first quadrant, they are positive. So this is just for your knowledge and how to understand it. Now let's get to the basics and do what is understandable. Now this other part here, that's just a reduction to reduce an angle referring to the quadrant. We'll come back to this part when we do the next topic on the other lessons. Okay, I want us to come to the solution part. This is the general solution we're talking about here. General solution. Here, they will just give you simple trig ratios, 2 or 3 of them in one part. You have to work them out. Nothing difficult. Same thing that you know, same knowledge that you know. But before that, you must understand 1 or 2 stuff. And upon those 1 or 2 stuff, here we are. Where are those? Here we are. The summary of these characteristics of each and every graph. But this one, I'm breaching the contract of the other lesson. But I want you to understand just one part so that we can understand one another. How do we find the period? Because we're going to use it later. So when we find the period, here we are given the standard form of a graph. It can be sine, it can be cos, it can be tan. So A here represents the coefficient of that value, of that trig ratio. Then B here, it represents the what? The coefficient of what? Of the angle. X represents the angle. and then B represent the coefficient of an angle. The same way here, A represent the coefficient of a trig ratio and B represent the coefficient of an angle. But here, A represent the coefficient of trig ratio, while still B represent the coefficient of an angle. Good. The domain we are meaning where is the graph starting and where is the graph ending, meaning the complete shape of a graph. The complete shape of a graph of a sine, let me use a different one. For example, regardless of A is positive or negative, it has to be an S shape in this format. It has to be an S shape in this format. So it means it takes 360 to make what? To make up this shape. Let's go to the cos. Cos is a shape like in this way. Let's use green. Cos is a shape in this manner. Start like this, and arm coming down, regardless of the value of R, and then this is our cos. So for this shape to appear on a graph or on the set of axes, we have to see that the period of the graph is now 360 initially. Now let's go to tan. Tan is 90. So tan being 90, it means on the other parts, we are now given the domain. We can see all of them read 9. Negative 90 to 0, when you check the distance there, the angles is 90. From negative 90 to negative 270, it's just when you check it's 90. You will get to there. This one is 90, and also it gives you 90 and another 90, which means it's 290 divided here. There are 180 part. 290 are divided into one part. So you will see and you will understand. This one, it has the what we call the asymptote, where it doesn't touch. Then it has a lot of them. The graph can be drawn in the same shape, but in this quadrant, sorry, in these domains, in this part, the first line can be drawn. It's something like a shape of this one, or it can be the shape of how is it like this? If it can other way. So it can be drawn in this section, and also be drawn in this section, and also be drawn in this section. The same shape. Going further. Now, I want to come to is the period. The period of the graph, if the graph is complete, automatically is 360. And then how do we determine the period of the graph? We look at the coefficient of an angle. Coefficient of an angle, which is B here, it means we will say if it's sine, we will say 360 divided by the value of B. Here we just give example that let's assume B is 1. So which means the period of the graph is 360. Now, note these things. We are going to look at them and we are going to use them in the later state. Now, if it's cos, the same value of B, if it was 2 here, it means we're going to say 360 divided by 2. This shape of the graph, it will be completed in 180. Just for example. Now, the period of tan period is 180. So being 180, it means, so let's assume the value of B is 1, then it's 180 divided by 1 is 180. If it was 2, we're going to have 90. So that's how we go, and that's how I want us to understand this part so that we can now do what is required of us. Now, with this being said, let's see what we do here in general solution. I'll just choose 1 or 2 of these questions for you to instill your understanding. Not with everything that you can consume in one day, but in doing, everything is possible. I'm having A up to H. I'll just choose 3 so that the rest, I leave them for you. Number 1 is A. Okay, it's sine to the power of 2. So then x to the power of 2 must multiply by cos x is equals to 0. Now, at first, make sure that your whole thing is equals to 0. Make sure that your whole thing is equals to 0, 0, 0. Let everything be equals to 0. If there is any value on one side, I don't know if my camera is visible. Sometimes it used to be blurry. Yeah, it's visible. Yeah? Okay. It has to be equals to 0. Now, being equals to 0, it's for you to know that we can now start simplifying and working out. Now we are having 2 different ratios here. The first ratio sine, the second ratio is cos. So in simple, we have to work out with a single ratio if possible. But if it's not possible, let's see what we can work with, and then if it can be simplified and factorized, we can work with it. If it cannot be simplified and factorized, it means we have to change one of the trig ratio into other. Automatically here we can change sine into cos, cos into sine, because we are having two sines here. If we have to change sine to cos, we change this and also this sine. It's going to be difficult. So simply, let's first, if it cannot be factorized and it cannot be simplified before we can change this one. Because if it can be simplified, it's going to be easy. Let's see. Since it's equals to 0, it's going to be easy to work on the left-hand side. We have two of the signs, and we also have one side. It means I can say one sine outside and open the brackets. There's one multiply with this one, the power of 2, which is 1. And then here is negative. Then this sign multiplied by this one here is going to give me this thing. And here it's going to give us what? It's going to give us, if I'm not mistaken, it's going to give us cos. Then the whole thing is equals to 0. So when I have to take this thing back and see if it gives me the correct thing, then I have to prove it in mathematics. If you're not sure, you prove. Let's see. Mathematics will say this one times this one will give power of sign in between is negative. Sine multiplied by this cos is going to give me sine angle, cos angle, and everything is equal to 0. You see now, the two things are now the same, which means that we are now correct when we say that we factorize it in that way. Now let's go further and simplify and give us equation. The first part, which is sine x, is equals to 0, which is the one is equals to the 0 side. Therefore, or the remaining part, which is sine x minus x, is equals to 0. This is the second part. Now, coming back, how to get rid of this sign to remain with x? Because we are looking at the angles. Let's this part here. Let's leave this part here. We'll come back to it. Let's work on the right-hand side. Now, here we have to solve. Change one of the sign, which means I mean cos or sine. When I say one of the sign, we can change the ratio of sine or the ratio of cos into one another, or we can take this one to the other side of equation side and multiply by negative, which we will have something like sin x is equal to cos x, because negative multiplied by negative will carry this side. It's going to give us positive. Then how do we then get rid of this one? We can divide both sides by cos angle. When we divide both sides by cos angle, you divide by u, then cos and sine, they give me a new term, and then this side remains with 1. Now, which means now the two things are now on the same level. One single trig ratio is equals to the number. Then what do? We go back to the calculator. And how do we work up on a calculator? On a calculator, it's not going to be that difficult. It's just going to be simple as like this one. We are going to, okay, calculator, please. Oh, okay, on a calculator somehow running away from me. Okay, here's my calculator. On my calculator, I will something like a. Okay. I will have to say, start by removing this sign this side. I will press shift on my calculator, and then I will press sign. And then I will put the value, the remaining x, and I'll have shift one arc, and then in the bracket, I will decide which is 0. Then I will put 0. I'll close the bracket, then I'll press equal sign. So which means now the value of x is equals to 0. So 0 as it is, I stay there for now. And then on the second part, you can see the other part of the screen because I'm monitor. And on the equals 1, then I'll say shift, I will say turn, and then I'll put 1, then I'll close the bracket. And then on my calculator, it gives me 45. Now, giving me 45, and then I come back, I will say remaining x is equals to shift 1, then x becomes 45. So the first part, x gives me 0 when I substitute the sign, the 0 on it. The second one, I substitute, put 1 and substitute 1, it gives 45. So yeah, it's 45 degree on the, so which means now I'm having my two angles. I'm having my two angles. So now here I'm working with tan, here I'm working with what? With a sine. So the simple last part that is very important on trigonometry. Now, let's see. This angle, we must remove it from 180. And also this one, we must also remove it from 180. Let's see, when we remove 0 from 180, we remain with 180. When we, without, even if it was negative here, we weren't going to say 180 minus 45. We're still going to say 180 45. We just remove the angle without its sign, which means positive. So then I will have something like I will have something like, let me just write here. I'll have something like 180 minus 45, which will gives me what is it? 135. 135. So which means now here angles are 45 and also 130. Not pushing us. Now let's do the last part of the importance of general solution. Coming to back to sine here, it's going to be 180 minus 0, which is going to be 180. Then I will say x values is equals to 0 plus or minus k multiplied by 360. This is the period of the graph. Period of the graph, we look at where we have sorted x equated into other one is this part. We only look at this part and see what is the coefficient of x. The coefficient 1, because there's nothing written, it's just 1. So we're going to say 360 divided by 1. Remember that one of sine, right? Now on tan, oh, it's not done. We'll also have x is equals to 180 plus k 360. Now the second one, this one of tan, the coefficient here is still 1. From tan coming from 180, it's not 360. Then we will have the first solution as x is equal to 45 plus k 180. The second one will have 135 plus 80. So these are the solution, possible general solutions of this equation, the original, which is this one. And these are the possible general solution. And that's what they are looking for. They want to see this last solution. Don't forget them. Yeah, on the next example, remember I'm saying I'm taking 3 of them that are different. The first number A that we took, it was its unique solution. So if we go and take number B, also its unique solution. If we take number C, it's its unique solution. So it's number D. But now I want us to start with number F before we can go to the last part of it that we do different one. We take number F. Number F, it's in this many ways. Where is number F? Number F, let me up the screen fast. Okay, number F says that 2 multiplied by cos squared angle is x plus cos angle is x minus 1 is equals to 0. So automatically our so-called equation is in standard equation. It's in standard way. It's equals to 0. No need of bringing someone to the other. But then here, we cannot use the same procedure we used on the other part. Here we can use the 2 ways. Either we stick with that one and until it works for us, or we create the one that we understand very easy. Why? Because this one, it's only single ratio, which is cost. It's cost. It doesn't mean anything. It's just that it means they are there. So we don't change it. We don't make it have an effect here. Let's leave the number as it is. We have trig ratio, which is cos only here. So the highest degree of this part is to the power of 2. Here there's nothing, it means it's to the power of 1. So how do we do? We used to know that cos x. Guy read that something like this: 2 multiplied by cos x1 multiplied by cos x2 plus cos x minus 1 is equals to. I'm just simplifying it for everyone to understand it without questions. Remember, when we say here multiply by this one, multiply by this one, if they are the same, they can say to the exponent of 2. When we multiply the power of the same base, we add the exponents. This is the same thing. So it means when I want to factorize, I cannot say, come on, there is x here, so there is cos x, there is cos x. I cannot say cos x outside, and then I'll say cos x minus or multiply by cos x plus 1. No, I cannot do that because can only minus 1 at the end. So that proves, that's why I said the method of the other side, it can't work for us until we do it the way it has to be done. Even if, yes, we can do it, but we have to do it with understanding. Knowing, or even if next time other questions similar to this one that are doable in this way, let's use this method that can work for all of them without assuming the assumptions that are end up in giving us the wrong things. Remember, here we're applying for the marks. So simply, the highest degree here is to the power of 2. So the common thing here is cos x. Instead of factorizing in the brackets, we say that cos x, let me write this side. We say that let cos x equals to, let's just choose any letter, b equals to letter k, which means wherever I will see cos x, I will put letter A. So letter K, yes. And then I'll go back to this one. Remember, this one was just a simulation of an example. This one was just an example showing you how we get to the power of 2. So simply now I'm checking, since my equation is equals to 0, and then my cos x come to say 2. I will say wherever I see cos x, I put letter K. Let's see. Without ignoring anything, this is the first part where letter cos x, so letter cos x is here, and also cos x is also here. That's why I'm putting my letter K. So which means I will say what? 2 letter K. There's an exponent of 2 here. Plus here is what? Is K minus 1 is equals to 0. See now, my equation now simplified in manner of what I understand in trigonometry, sorry, in the first or solve for x algebra. So what is the next? So what is the next step? The next step is when we solve it in this way. It's a quadratic. It's quadratic. So now I'm using an advanced calculator. Last time you were not. I was saying that I don't have a calculator. So today I'm prepared. I'm with a calculator. You can't do anything. Now here is our calculator. Let's see how we solve x on this calculator. And then on yours, you can only solve x out towards the examination. Now let's do it manual to understand. So mine, I'll just press mode, and then I will look for this one. And then the value of A here is 2. And then the value of B here is 1. B is this side. B is this side. You can see the camera. B is supposed to be, which is 1, equals to value of C, it's minus 1. It's equals to on my calculator. And I'm done. Just press equals to. The x number 1 is equals to x number 1 is equals to minus 1. So our k number 1 is equals to minus 1, or k number 2 is equals to 1 over 2. That's simple. It helps me calculate solving for x. Or we can now, let me remove it. We can now, and don't ask me how to get this calculator, please. Not important for you. Okay, now we come here. We end up, since now I know my values, I can break. I can use quadratic formula that says that if A is equals to 2, B is equals to 1, C is equals to minus 1, then the value that I'm looking for is K. It's minus B plus or minus root of B squared minus 4AC divided by 2A. If you know this formula, is also there at the back of your formula sheet. And then if you know this formula, you will know that here you will substitute 2, 2. Here you substitute, here substitute 1, 1, because it's B. Sorry, I made a mistake. Then 2 is going to be here and also here. 6 minus 1 is going to be here. On substitute, then you punch on a calculator, it will give you exactly as mine, saying that K is equals to minus 1. The second one, when you change this one, you put negative and plus here, you're going to give K is equals to 1 over 2. That's what it gives you. Then after here, we remembered that we said where there is K, there must be what? Cos X. Now we change K into cos X. Then we will have cos X is equals to minus 1. The second one, we will have cos X is equals to 1 over 2. That's the part of it. And then remember, how do we remove this one to end up with the angle? We have to do what? We have to say shift. And let's shift and see how we work on this one. Let's shift and see, my people. When we shift and see it, what does it give us? Let's come back to my calculator. Nice calculator. I like it. Let's shift and see. We shift and see what? We shift and say cos. Shift. Then we say cos. Cos what? Minus 1. Then what is cos? Shift cos minus 1. It's 180. So which means here x is equals to 180. That's the first part. Second part, we go this side. Shift cos 1 over 2. Shift cos 1 over 2. Shift cos 1 over 2. 1 over 2 gives me 60. So x is equals to 180 and or x is equals to 60. Okay, we go back to our studio. Here we are. So we've been here. We now see, we're not forgetting that what we should do or what we should be doing is to say that this one here, the coefficient of x is 1. If there's nothing written, is 1, and also here. Then it means for this angle we get here, we must minus it from 180, which is 0. So the first x, we will say x is equals to 180 plus k 360. Remember, the period of cos is 360 divided by the coefficient of x here. So if it's 1, it's just 360. Or the second one, which is 0 plus k 360. How do we get 0? 180 minus 180, it gives us 0. That's the first part. The second part, when x is 60, we'll say 60 minus 180 minus 60, which will gives us 120. Then I will say x is equals to 60 plus or minus k 360. Still the coefficient here is 1. And also the second one, which is what? Which is 120 plus minus K360. Okay, let's proceed then. As we proceed, I want to look for the difficult one that we cannot just simply attempt. Let's look at number C. Number C. Number C, it looks interesting. Okay, let's look at number C here. Number C, number C, number C. Number C, number C, number C. This is number C. You see, there's something you are not used to. But this one, number C, is very simple. Sometimes these things, they look difficult if you don't know what you're doing. Now, it's simple. I will do without you asking me any questions. Choose another is difficult. It's just for you to rewind your mind. I will do number C by just explaining only, by just that impression. Hey, it was so easy. Hey, and you're done. It was hey. Even though it looks longer, but it's hey, it's done. Okay, let's see. Doing here, we will have something like there are two ways we can also do it this one, and the other way I don't want to teach you because it's for shortcut and it's very simple. Let's do it the wrong way, the long way. Sorry, we are having negative cos angle sine bracket minus 10. Okay. It might be looking difficult. This one is a compound angle. If that's the first option, change it into a single, into a compound angle. It will give you a Let's see how we change it into a compound one. Compound one will have sine x multiplied by cos 10 minus x multiplied by sine 10. And the option always works. So the shortcut one, it has to work on the other way. So let's leave the shortcut one and do this one in this manner. Now this one cos 10 is a special angle. You can just, sorry, it's not a special angle. It's an angle, it's a value. You can just punch it on a calculator, round your number to 3 decimal places because it's not the final answer. And then you will see to it how much does it give you. Let's see here, and let's see here. Where is my screen? Okay. Let's see here. I'm having cos 10 and sine 10. Okay. Okay, cos 10 is going to give me 0.984. I have negative cos x is equals to 0.984. Okay, let me take 985 decimal place and then multiply by sine x minus, and then sine 10. What is sine 10? Sine 10, sine 10. Sine 10 is 0.174 cos x. Okay. Now with this one, I will have to work mathematically. Work it mathematically, please leave me. So it means what I'm having cos and also sin at the same time. So I can take this negative cos to the other side. Then I will have negative cos x. This one will become positive on this side. That will give me plus 0.174 cos x is equals to 0.985 sine x. Remember, it's always a way for it to work out. So here, it's more like I'm having a negative 1, sorry, negative 1. Here, I get it's negative, so it means it's 1. It's negative 1 cos. So negative 1 cos plus 0.174. Then it gives me negative 0.826 what cos x, which is equals to 0.985 sine x. So what do I do? Now I'm having trig ratio in another. I can divide by the other one that can change into other trig ratio. Now I can divide both sides by cos x. So when I divide both sides by cos x, here I remain with what? With negative 0.826, which is equals to 0.985 sine over cos. It becomes tan angle. Then I divide both sides by the number, which is 0.985, both sides 0.985, then which is equals to, let's see, then when we have a negative 0.826 divided by 985, what does it give us? It gives us 0.000. It gives us 0.00083857868, which is equals to tan angle. So what will I do? I will say shift tan gives me the value. Then let's see. I'll say shift tan. My calculator. Shift tan the value, which is, oh, it's negative. Sorry, it's negative 0.25 right 0.9. Then it's going to give me something like negative 39.9. 0.98. 2 decimal place, since it's the final answer, then 2 decimal place. This is what will gives me on my calculations. And then angle A1, I have to remove it from trig ratio, which was tan, and the coefficient here was 1. So it means I remove it from 180. Then I will say, I don't take it negative, because even when you take it negative, it's wrong. I'll just say 180 minus 39.98, which will gives me something like 140. 140.02. So now the values of x here on this trig ratio, solving x, the first x is equals to negative 39.98. Get tan, right? So tan again, get plus or minus k180. Don't forget that. And then or x can be what? It can be 140.02 plus minus k180. These are the possible solutions of this equation in the manner without any shortcut. I know I might have done it in a manner that you can't figure it out, but all the steps according to what I have done here, I haven't skipped any. Let's look at number G. I will prefer number G over E if it's me, because you check well. Number E, it's more or less the same as number A, but we do it in a manner of number B. You see, it means now you already know the knowledge. But number G is in the same manner of number B, but we have to simplify it first. Let's see, 6 of sine to the power of 2x minus cos x is equal to 5. Okay, let me remove the screen. Matata. This one is not equals to 0. So if it's not equal to 0, don't forget that we simplify. And here we are having two trig ratios. The first one, which is sine, the second one, which is cos. And we can work on that. We can't compromise to use the first solution that we used on the first question. No, we can't do that. So what do? Let's change one if it can be changed. Sine to the power of 2, it can be changed into cos. How so? We will have 6 into brackets 1 minus cos to the power of 2x. This is the identity of 1. Identity of 1 said that 1 is equal to sine to the power of 2x plus, so 2 angle plus cos to the power of 2 angle. No, squared, sorry, not 2 angle, 2, like this one. So if I want sine to the power of 2, I will take cos to the power of 2 to the other side. Then I'll have 1 minus cos. That's what I put here. Just give you an example, demonstration of how to do it. And then, which means now I got rid of sine. What do? I simplify by taking also 5 from the other side into this side. I will multiply it by negative. Then the other side remains 0. Then here I simplify, removing the brackets. I will have 6 minus 6 cos squared x minus cos x minus 5 is equals to 0. The numbers aside, then minus 6 cos squared x minus cos x minus 6 plus, sorry, minus 5 plus 6 here. And as is it coming equals to 0, then I will say simply minus 6 cos squared x minus cos x plus 1 is equals to 0. Now, this is our standard equation where a value of A, let's not forget that. The highest degree here is to the power of 2. Here it is cos. It's more like a quadratic, saying like minus 6 cos x multiplied by cos x minus cos x plus 1 is equals to 0. Remember how we solved this one? We said that we're looking for the value of, or we're looking for cos x. Wherever we see cos x, we say let cos x equals to the value of k. So which means wherever we see k, cos x, we will put what? K. Then we will have something like this one in our formula. And in this manner, we know very well that the value of A has to be here, which is minus 6. The value of B has to be here. If there's nothing, it means there is 1. Then the value of C is the last number. So C is equals to 1. And then this is how quickly we do it with back. You see now, the different thing it might be how the reducing the one single click ratio. If you now know what to do, it's not going to be difficult. Automatically, when you look at it in this way, you know how to solve this. You know this one is a quadratic one because it has to the power of 2. So it should be in your mind. It should be working for you every time the question. You must be seeing or how you solve the question to get to the answer. If you are not, it means your math is doing you. You must do more of the math questions so that you can now, when looking at the question, you already know the possible step that you can take. Or if you can take this step, it won't make you stuck in future. You just take this step and then you continue doing it right. You will get it correct. Now let's do it on my calculator and see if it can work for everyone. You know, my calculator is always right. Now on my calculator, I will have something like, I like my calculator because it doesn't take a while. Let me solve for x. Look what I solve for x. It doesn't take a while. I just solve for x so simple. The value of A is minus 6. I'll put minus 6 equals to value of B is minus 1. Value of C is 1. So the first x is equals to 1 over 3. So this one I will leave here for the sake of space. I don't know what can I use. Let me just grab a blank paper somewhere. Okay. For the sake of space, I will just use this blank paper. I'll retrieve. Then I will have k equals to 1 over 3. The second value, k is equals to minus 1 over 2. These are the two values of k that we found. Remember, or in k is equals to cos x. So x is equals to 1 over 3, or cos x is equals to 1 over minus 1 over 2. Then how do we work out? Say shift. And forget that. Don't ever, ever, ever forget shift. Don't ever forget shift, because if you do forget shift, you're finished. Shift 1 over 3. Cos shift 1 over 3. And x, it becomes 70,53. Put decimal place. Or x is equals to shift negative 1 over 2. Gives me 120 exactly. So with this one, we have first part, let's work with 70 plus 70. Well, let's work with 70. So we'll say what? We'll say 180 minus 70,53, which will give you what? Will give you x, another x is equals to 109,47. So which means for the value of x is equals to 70,53 plus or minus k360 equals, right? And a single angle. And then another one, x is equals to 109,47 plus minus k 360. That is the first part. We are done with the first part. Let's work on the second part when x is 180. So this is 120. Now on the 120, we'll say 180 minus 120, which will gives you x is equals to 60. Then the first solution is x is equals to 120 plus or minus k360 is still cos, right? Cos is 360, the period. X is equals to 60 plus or minus k360. Now these are the possible solutions of this general solution formula. And if you still find it difficult to understand these things, I know very well that you may give an excuse of something, but there is nothing that I haven't done or do so far. So which means that this was the question that we must focus on. If you have any question from my side, my lesson is complete. If you have any question, you can ask the question now.